Alright, these are the notes 7E. We're going to be adding and subtracting rational expressions. So take a moment and write down the following notes. To add or subtract, you can only add or subtract fractions with like denominators. You may need to find the least common multiple. And finally, to find the least common multiple, you must first factor each expression. The least common multiple contains this greatest number of times it appears as a factor. And I'll illustrate this in a moment. Alright, also write down the following problem. You'll be taking these on your own paper. If you need to, pause the video if you need more time. Alright, the first thing we're going to do is factor the expressions that we see. So let's factor everything that we have up there first that we can. So I'm going to rewrite this as x over, we're going to factor an x out, which leaves us x times x minus 6, minus 6. Here again, factor out another x. We're going to get x minus 6. Now this particular example already has common denominators. The denominators are exactly alike. So that means we keep the denominator and we combine the numerators. So the numerator is going to become x minus 6. Alright, now let's stop for a moment and talk about the domain on this. Remember, our denominators are not allowed to be 0. So that means the domain on this expression, x cannot equal 0 and x cannot equal 6. Because we're not allowed to have 0 in the denominator. Alright, so now let's see if we can simplify this any further. Notice that our numerator, so our common factor, we have an x minus 6 in our numerator and an x minus 6 in our denominator, which equals 1. So that means when we simplify this, we're going to be left with 1 over x. So here's an example where we already had common denominators. Let's look at one where we don't have common denominators. So example number 2. Alright, take a moment, write down that problem. Alright, to find that least common denominator, we're going to factor. We're going to factor all the numerators and the denominators that we have there. Factor everything. Alright, so our first numerator. Our lead coefficient is negative, so that means we need to factor out a negative 1. So I'll factor out a negative, which leaves us with x minus 1. Alright, let's factor this denominator. What multiplies to give you 2, but adds to give you negative 3. So we're going to get x minus 2, x minus 1. Minus, alright, here again, x plus 3 is a common factor. They're grouped together. They cannot be separated. The denominator, we're going to factor out a 3 and leave us with x minus 2. Alright, let's look at what we have here. We can't simplify across the minus here, but we can within the same fraction here. We can simplify. So it's easier to simplify as soon as you can because you have less to carry along in your problem. So in this case, x minus 1 over x minus 1 gives us 1. So let's rewrite what we have left. So we have negative 1 over x minus 2 minus x plus 3 over 3 times x minus 2. Alright, notice we don't have common denominators. The denominators are not exactly the same. So that means we're going to have to do some math to get them to be exactly the same. Alright, to make a common denominator, you want every different factor. So in this case, we have a factor of x minus 2. It's repeated, but the highest power it appears in either one of our expressions is the first power. We also have a 3. So that means our common denominator is going to be 3 times x minus 2. So now we got to look at what do we need to multiply our original fraction by, this one, our first fraction, in order to get 3 times x minus 2. What's missing? If you compare this to this, what are we missing? Well, of course, we're missing a 3. So that means we need to multiply the numerator and the denominator by 3. 3 over 3 is 1, so we're not changing the expression. All right, look at our second fraction. We want 3 times x minus 2. We've got 3 times x minus 2. That means I don't need to multiply anything. It's already got the same denominators that I'm looking for. So let's simplify. Let's combine it to a single fraction. So my numerator is going to be 3 times negative 1, which is negative 3. Here, this is minus the expression x plus 3. Don't forget to distribute that negative. All right, cleanup time. So we're going to have negative 3 minus x minus 3 over 3 times x minus 2. So my numerator is going to give me negative x minus 6 over 3 times x minus 2. All right, a lot of times, and that's a fine answer. That we can't simplify. We don't have any common factors. All right, I really can't simplify that any further. But there can be a couple of different ways this expression can be left. If you look at the numerator, you could factor out a negative 1. So it gives me x plus 6 over 3 times x minus 2. That's one way your answer. That's an equivalent answer. All right, sometimes they'll put the negative out front, and you'll see x plus 6, distribute that 3 back, 3x minus 6. And that could be an answer with the negative out front. It just depends on whoever's making the multiple choice how they choose to leave the final answer. Those are all equivalent answers. And on a free response, they would all be counted as correct. One is not more simplified than the other ones. Just I want you to realize there's different ways to write that final answer. All right, let's look at another example. This one actually came off an old SOL. So take a moment, write down that problem. All right, when I look at this problem, I've got A's and B's. But notice that, okay, so in this first expression, my A comes first. But in these second expressions, my B comes first. So I'm going to have to get consistent in how I would standard form. I want to get consistent in how I write these terms. So typically, standard form means alphabetical order. So I'm going to rewrite, before I do anything else, is rewrite those expressions, second expressions, with the A first. Otherwise, I'm not going to get this as simplified as I need it to be. All right, so let's rewrite that. So I'm going to make this b squared over, now in a moment I'm going to factor that bottom term. For right now, I'm just going to do one thing at a time. Plus, I'm going to make this negative a plus b and negative 2a plus b. All right, in order to find my common denominator, I need to factor everything. All right, so my b squared term, of course, is not going to factor. All right, let's factor this trinomial. Take a moment, factor that. So I'm just going to make it 2a minus b, 2a minus b. All right, plus, all right, here, my lead factor is negative, so I'm going to factor out a negative 1, which leaves me with a minus b. Here again, my bottom expression, I need to factor out a negative 1, which leaves me with 2a minus b. All right, let's look and see if we can simplify anything. Notice in this second expression, the second part of the second fraction, I have negative 1 over negative 1. Those divide out. All right, so I'm going to be able to cancel those out because they're within the same fraction. So, all right, let's see what we got left. We got b squared over 2a minus b squared plus a minus b over 2a minus b. Now we need to get our common denominator. All right, so we only have one factor, all right, that 2a minus b. But notice here that it appears twice. So that's the largest number of times that it appears in a single fraction. So that means my common denominator is going to be 2a minus b squared. All right, let's see what we need to get a common denominator now. So my first fraction, all right, I want 2a minus b squared. I've got 2a minus b squared, so I don't need anything. So I'm not going to change my numerator at all. So that's going to be b squared. All right, and my second fraction, however, I need another 2a minus b. So I need to go 2a minus b over 2a minus b. So that's going to give me plus a minus b over 2a minus b. All right, cleanup time. Now it's just algebra. All right, let's FOIL that expression. So we got b squared plus, all right, let's see, we're going to get 2a squared minus 3ab plus b squared all over 2a minus b squared. All right, combine like terms. We're going to get 2a squared minus 3ab plus 2b squared over 2a minus b squared. All right, let's see if that numerator can factor. See if we have any common factors once we factor that numerator. Does anything multiply to give us 4, positive 4, and add to give us negative 3? No, because 4 and 1, we'd have to have a negative 4, and that would be a positive 4. So that's not going to factor. So this doesn't factor. So this is our final answer. All right, let's look at a new type of problem. This is called a complex fraction because it's a fraction over a fraction. We got two or multiple fraction bars in here. And when we simplify, we're not allowed to leave it that way. We can't have all those fraction bars, so we got to get it down to a single fraction. All right, so what that means here, first of all, I see I'm dividing, so I'm going to be flipping this bottom, but I can only flip this once it's a single fraction. This has to be a single fraction. So that means I'm going to have to work on that denominator and get that to have a common denominator to combine that and make a single fraction. Okay, so let's do this. We're going to have 7 over x minus 2. The numerator's fine. All right, let's work on the bottom. All right, different factors. I have an x and I have an x minus 2. So that means my common factor, my least common denominator is going to be x times x minus 2. All right, working on the numerator. So I want x times x minus 2. I only have an x, so that means I need another x minus 2. All right, here I have an x minus 2. I want x times x minus 2, so that means I need another x. All right, cleanup time. So we're going to have 5 times x minus 2 plus 1 times x is x. Now I have a single fraction. This is a single fraction. So now I can flip and multiply. I want to flip and multiply, but not until, you cannot do that until you have that denominator a single fraction. So this is going to become 7 over x minus 2 times x minus 2 over 5x minus 10 plus x. All right, let's see. Now we're multiplication, and I can cross out common factors. All right, so I've got x minus 2 in the numerator and the denominator, so that's going to be 1. So I can cross those out, leaving me with 7x over, let's simplify this expression, 6x minus 10. All right, I could factor out a 2 in the denominator, 7x over 2, 3x minus 5. It really doesn't help me simplify anything else any further. So either one of these would be fine final answers. All right, so remember the complex fraction, you're only allowed to, when you simplify it, it's only allowed to be a single fraction. Complex fractions just mean a fraction over another fraction. All right, let's look at another example. Here again, this came off an old SOL. All right, notice that we already have a single fraction in the numerator and denominator. So I can go ahead and flip this entire denominator and multiply. Flip and multiply. Okay, I'm going to do that first, and then I'll go back and factor, because I don't want to do too many things at once. All right, so let's go ahead and do that. So I'm going to rewrite this as 6x minus 6, 6x squared minus 6 over 8x squared plus 8x times 4x squared plus 4x over, all right, here, I need to rewrite that in standard form. So I am going to change that and make that negative 3x plus 3. Otherwise, I'm not going to get this thing simplified enough. So I just rewrite that expression in standard form. All right, now everything gets factored. So let's factor out a 6, which leaves me with x squared minus 1. You should notice that's going to factor again. All right, I'll do that in a moment. Factor out an 8x, that leaves me with x plus 1. Factor out a 4x, that leaves me with x plus 1. And factor out a negative 3, that leaves me with x minus 1. All right, let's factor this again, and then I'll start simplifying. So 6 times x minus 1, x plus 1, over 8x, x plus 1, times 4x, x plus 1, over negative 3, x minus 1. All right, let's start simplifying. Crossing out common factors. So who's out? X plus 1, x plus 1. Since it's multiplication, I do not have to have a common denominator. Everything's multiplication now. So I can cross out x minus 1, x minus 1. All right, let's clean up and see what we have left, and then we'll see if we've simplified enough. So in my numerator, what do I have left? 6 and 4x. So that's 24x. And don't forget about that x plus 1. All right, in the denominator, I have negative 24x. All right. So negative 24x into positive 24x gives me a negative. I'm still left with my x plus 1. That's an okay answer. We can distribute our negative, and that's also a correct answer. So you need to be able to factor very well. Give yourself lots of room on these. It's very easy to make a mistake because you copy or drop a negative, copy something down incorrectly. So here again, make sure you're giving yourself lots of space to work out these questions. If you need more time, please pause the video, or you can rewind it if you missed something. All right, you try one. Try this one. See if you got this. So take a moment, write down the problem, pause the video, try it, and then restart the video to check your answer. All right, pause the video now and try the problem. All right, here's how I worked it out. Hopefully, like I said, you've got an answer. Let's see how you did. All right, when I look at this, all right, I'm subtracting. That means I need a common denominator. Adding and subtracting, you got to get a common denominator. So that means I'm going to factor everything. So I'm going to factor what I can. So I've got a common, so I got x plus 3, x minus 5. Those are factors. It cannot be separated. Treat them like it's a single number. All right, I'm going to factor this first denominator. So I'm going to get x minus 4, x plus 2. All right, let's factor that second denominator. I'm going to get x minus 8 and x minus 4. Take a moment to check and make sure, like I said, you factor correctly. All right, I need a common denominator. I want every different factor that I had. It's the largest number of times it appears in a single expression. So they only appear one time in each expression. So that means my common denominator is going to be x minus 4, x plus 2, and x minus 8. All right, so let's see. What do I need to get in my numerator? All right, I've got x minus 4, x plus 2, but I need an x minus 8. So I'm going to multiply the numerator times x minus 8 and the denominator times x minus 8. So that's going to give me my new numerator is going to be x plus 3, x minus 8, All right, my second fraction. What am I missing? I need an x plus 2. All right, let's see what I need. I need x plus 2. So I'm going to multiply the numerator times x plus 2 and the denominator times x plus 2. Same thing as multiplying by 1. Identity property. All right, so what do I got? I got minus, don't forget that minus, x minus 5, x plus 2. All right, here comes the algebra. I've got a FOIL. Let's clean this up and see if we can get rid of anything else. So let's FOIL. I'm foiling this first expression here. I'm foiling here. So I'm going to get x squared minus 5x minus 24 minus, I distribute that negative, so I'm still keeping my parentheses. All right, I'm going to FOIL the second expression. FOIL this. I'm going to get x squared minus 3x minus 10. All over, do not drop that denominator. Some people want to throw away that denominator, but you can't. It's got to follow you all the way through the problem. So you start off with a fraction, you're probably going to end up with a fractional answer. Okay, let's combine like terms in the top. So I got x squared minus 5x minus 24 minus x plus 3x plus 10 all over my common denominator. Do not multiply this back together. Possibly at the end, but not yet. Now, see if you can get any common factors out of the numerator first. All right, combining like terms. All right, x squared minus x squared, well, that's 0. Negative 5x plus 3x, that's negative 2x. Negative 24 plus 10, that's negative 14 over my common denominator. Like I said, you cannot throw away that denominator. All right, you could possibly factor out a negative 2 out the numerator. That becomes negative 2 times x plus 7. And we don't have any common factors in our denominator, so we got to keep that entire denominator. You do not have to multiply these back together. You can leave it in factored form like this. You can, all right, but you don't have to. So that's your final answer, and hopefully you got the same thing. All right, like I said, if I went too fast or anything, please, rewind and watch again till you've got all of these notes. All right, thank you, and I'll see you in class.